wondered what the next giant leap in technology looks like? I mean, a leap so big it makes today's supercomputers look like pocket calculators. Well, that's what we're talking about today. We are diving headfirst into the absolutely mind-bending world of quantum computing. Just imagine for a second a machine that could solve problems in minutes, that would take our best, most powerful supercomputers thousands, maybe even millions of years to figure out. Seriously, think about that. What could we as a species do with that kind of power?
And here's the kicker. This isn't some far off science fiction dream. This is a real technology that's being built right now, and it's on the verge of changing pretty much everything we know. This is quantum computing.
All right, so to really wrap our heads around this, we have to kind of leave our normal everyday logic at the door. We need to take a step into the very strange and frankly super weird world of the quantum realm. Okay, so where do we even start? Well, it all comes down to the most fundamental building block of information, the bit. And this, right here, is where everything we know about computing completely splits into two different universes. So your laptop, your phone, every digital device you've ever used runs on what we call classical bits. Think of them as simple light switches. They can either be off, which is a 0, or on, which is a 1. That's it. Billions of them, just flipping on and off. But a quantum bit, or what we call a qubit, now that's a whole different beast. A qubit can be a 0, it can be a 1, or, and this is the crazy part, it can be both at the exact same time.
Right, so how on earth is both at the same time even possible? It sounds like magic, doesn't it? Well, it's not technically magic, but it comes from two principles of quantum mechanics that are so bizarre, they might as well be. We're talking about superposition and entanglement. First up is superposition. This is the core idea that lets a qubit exist in this weird, ghostly blend of all its possible states at once. It's not a 0 or a 1, it's more like a cloud of probabilities containing both, right up until the very moment you try to look at it.
Let's use an analogy to make this a little clearer. Think of a coin. A classical bit is like a coin that has already landed on the table. You look at it, and it's either heads or it's tails. Simple, right? One definite answer.
Now, a qubit in superposition, that's like the coin while it's still spinning in the air. In that moment, it isn't heads or tails. It's kind of a mix of both possibilities at once. It only chooses a side when it's forced to land, or in the quantum world when we measure it. And that, right there, that's the secret sauce. Because qubits can hold all these possibilities at once, a quantum computer can explore a massive number of solutions simultaneously. A normal computer has to go down one path, see if it works, and if not, go all the way back and try another. A quantum computer basically tries all the paths at the same time. This is where its incredible power comes from. Now, for the second quantum superpower. This one was so strange, so deeply weird that even Albert Einstein couldn't quite get his head around it. He famously called it spooky action at a distance. He was talking about entanglement. Entanglement is this bizarre, almost telepathic connection between two qubits. Once you link them, they behave like a single entity. The state of one is forever tied to the state of the other. And the craziest part? It doesn't matter how far apart they are. They could be on opposite sides of the universe, and the connection is still instant. So here's a quick breakdown of how it works. You take two qubits and you entangle them. Then you can separate them by a mile or a million miles, it doesn't matter. The very instant you measure one of them and it decides to be a 0, you know instantly that its partner, wherever it is, has become a 1. It's like they have a shared destiny. This creates this incredible network of information within the computer. Okay, these ideas are definitely cool. A bit of a workout for the brain, for sure. But this isn't just a physics lecture. This power is being harnessed to solve some of the biggest, toughest problems we have. So let's talk about what this actually does in the real world. First up, something that affects every single one of us: cryptography. You know, the digital locks that protect our bank accounts, our private messages, our government secrets. Well, a powerful enough quantum computer could, in theory, shatter that encryption. And that reality has started a global race to invent new kinds of post-quantum security that even these machines can't break.
Next up, medicine and materials. See, nature itself, molecules, chemistry, biology, it all operates by the rules of quantum mechanics. Our best supercomputers today can only make educated guesses about how complex molecules work, but a quantum computer could simulate them perfectly. Imagine designing new medicines or creating revolutionary new materials for batteries or solar panels, atom by atom. It's a total game changer. And then you have problems of just massive complexity. Things like finding the absolute most efficient shipping routes for a global logistics company, or designing a traffic flow for an entire city that has no traffic jams, or even training smarter, more powerful artificial intelligence. These are optimization problems with a staggering number of variables. Quantum computers are tailor-made to sift through that chaos and find the perfect solution incredibly fast. So with all this unbelievable power, you gotta be wondering, right? Is this the end of the road for my laptop and my smartphone? Are these quantum machines just gonna make all our current computers obsolete? Well, not so fast. Before we get to that future, we have to face some absolutely enormous challenges. The very quantum weirdness that makes these things so powerful also makes them unbelievably delicate. I mean, we are talking about creating some of the most controlled environments on the entire planet. These qubits have to be kept colder than outer space. We're talking fractions of a degree above absolute zero. They need to be shielded from the tiniest vibration, a stray magnetic field, anything. The slightest disturbance can make the whole calculation collapse. It's a monumental engineering problem. So the future isn't about replacement. It's really about partnership. You're not going to be browsing social media or checking your email on a quantum computer. Our classical computers are still going to be the amazing workhorses for all of our everyday stuff. Quantum computers will be the specialists, the heavy hitters you call in for those monster problems that no other computer could even dream of solving. So, yeah, this is not a competition. Think of it more like a new, powerful hybrid system. Classical and quantum computers working hand in hand, each playing to its own unique strengths. Together, they're going to define a whole new era of discovery. We are literally at the dawn of a new computing age, learning to work with the fundamental rules of the universe itself. The quantum revolution isn't something that's coming in the distant future. It's already started. The only question left is, are you ready